Let's start with a question that sounds like it's straight out of a sci-fi movie, but is actually being explored in labs right now. Can a robot scientist do more than just follow our instructions? Can it actually learn? Because if it can, we might be looking at the start of a whole new scientific revolution.
So let's just cut right to the chase. Can a machine, an AI, a robot, genuinely discover something totally new, all by itself? Not just crunching numbers we give it, but true original discovery.
To even start to answer that, you need to get familiar with this term, this self-driving laboratory, or SDL. Now, this isn't just a robot arm in a corner. We're talking about a whole, fully autonomous system. It can come up with a hypothesis, design the experiment to test it, physically run that experiment, and then look at the results to figure out what to do next. All of it, with no human in the loop. These SDLs are really the peak of what we call the fourth paradigm of science. For centuries, science was about observing, then it was about theory, then we added computer simulations. Well, now we're in this fourth age, an era of data-intensive, automated discovery.
And make no mistake, these labs are just unbelievably powerful. They are a massive leap forward. We are talking about systems that can run experiments 24/7, generating more data in a week than a human team could in years. For things like creating new medicines or materials, it's a total game changer.
But, and this is a huge but, for all their incredible power, these amazing robot scientists have a giant fundamental problem. It's like they're a genius, but a genius with a very specific and very crippling case of amnesia. This table just lays out the problem perfectly. Think about a human scientist. With every experiment, you learn, you adapt, you build this intuition. But the current robot scientists? Nope. Their intelligence is basically frozen in time. Every single new project, it's like their first day on the job all over again. They start completely from scratch.
The researchers have a great term for this. They call it institutional amnesia. Even after processing mountains and mountains of data, the lab itself doesn't actually get any smarter. It's stuck as a perpetual novice, a super fast, super efficient intern that just never, ever gets promoted.
So, if that's the problem, what's the solution? Well, according to this research, it's not about a small tweak or a minor upgrade. It demands a completely new way of thinking about science itself. They're calling it the fifth paradigm. Take a look at this diagram. On the left, that's where we are now, the fourth paradigm. It's a loop and it's a powerful one. It reasons, it searches, it acts. But look at those key words: frozen, memoryless, hard-coded. It's a stiff, rigid system that does what it's told, but can't really evolve.
But now, look over to the right at the fifth paradigm. The entire vocabulary just flips. Suddenly, we're seeing words like learnability and continuous belief update. This isn't a static loop anymore. This is a dynamic system that's designed to grow and evolve.
And this is the absolute key, right here. The next big jump isn't about making the robots faster or the automation cleaner. It's about giving the entire laboratory the ability to learn, to turn it from a static tool into something more like a living organism, something that actually gets smarter over its entire lifetime.
Okay, so that sounds great, but how in the world do you build a lab that actually learns? The researchers came up with this really elegant framework they call the Trinity of Learnability. It breaks this massive idea down into 3 core pieces that all have to work together.
The easiest way to think about it is this. You need a brain, a strategy, and hands. And the trick is, all 3 of them need to be able to learn and get better over time. You have to learn to think, learn to strategize, and learn to physically do things.
So first up, you've got cognitive learnability. This is the brain. This is all about developing that scientific intuition we talked about. The lab creates a memory of every experiment it's ever run, all the successes, all the failures, and it uses that history to make smarter guesses and better hypotheses next time. It's literally learning how to be a scientist.
Next up is experiment learnability. That's the strategy. This is about working smarter, not harder. Instead of just trying every single one of a billion possibilities, the lab uses what it learns from one experiment to update its beliefs and then strategically decide what to try next. It learns how to find the needle in the haystack without turning over every single piece of hay.
And finally, and this is so important, you've got embodied learnability. These are the hands, because science happens in the real, messy, physical world. This is about the robot learning to get better at the actual physical tasks, handling liquids, mixing chemicals, using tools. It learns to adapt and gets more dexterous with practice, just like a human chemist would. All right, this all sounds absolutely incredible, but is it just a cool idea on a whiteboard or does it actually work? Well, that's the best part. The researchers didn't just dream this up, they went ahead and built it. They took this from theory to reality.
And they gave their new learning lab a really tough, real-world job. The challenge was to find the absolute best recipe for cleaning a common industrial pollutant out of wastewater. A super complex problem with a ton of different variables you have to get just right.
And when I say a ton of variables, I mean just look at the number of possible solutions they were facing. Over 200 million different combinations. To find the best one by just trying them all, forget about it. It would be practically impossible.
But remember, this lab was designed to learn. It didn't have to try everything. It used its brain, its strategy, and its hands to navigate that huge space intelligently. So the number of experiments it actually needed to find the best recipe? Just 15. From 200 million down to 15.
And the results were, well, they were just off the charts successful. The lab found a solution that was 99.7% effective at cleaning the water. And it took a process that would normally take 2 human scientists about a month, and it did the whole thing by itself in just 45 hours.
So, where does this all leave us? This isn't just about doing experiments faster. This is a fundamental change in how discovery itself can happen. We now have a blueprint for tools that don't just work for us, but that learn and evolve with us. It really makes you stop and wonder, if our labs can now get smarter with every single experiment, what challenges that we thought were impossible are suddenly on the table?